Okay, so I'm recording this so that you know what will be on the chapter 10 and 11 test that's coming up. And so, first of all, a few things. These are the equations here that will be given to you on the test. I know there's names of these, like the first one is called Boyle's Law, but there will be no questions about whose law is this or what's the name of that equation. You just need to be able to know how to use these equations on the test to solve any particular problem. So you'll be given a bunch of problems, and I'll show you what the problems are that will be on the test, the guide that's already posted on Schoology. But I want to, again, also explain to you what will be given to you on the test. So all the equations like these will be given to you on the test. The constant, the gas law constant R, will also be given to you, which is 0.0821 liters atmospheres per mole Kelvin. So this is, again, all given to you. So you just need to know how to use it. Also, one thing I want to point out, all the T's in every equation on here must be in kelvins. Reminder, Kelvin's temperature is equal to Celsius plus 273. The Kelvin temperature plus Celsius temperature Kelvin temperature is the Celsius temperature plus 273. Meaning 0 degrees Celsius is 273 kelvins. 100 degrees Celsius, 100 plus 273, is 373 kelvins. So, okay, great. So these equations will be given to you, but how am I supposed to know what to do and what kind of problems? So I want to show you, I'm going to do a few problems from the textbook. And I just grabbed the textbook, and we are going to look at that question number 32 2, not 32, 2 that is on the screen right now. And so it says a gas at 65 degrees Celsius, so the temperature is 65 degrees Celsius, occupies 4.22 liters. I wrote V equals 4.22 liters. How do I know it's a volume? Because it says liters. And how do I know 65 C is a temperature? Well, because it says Celsius. Oh, well, and it also says temperature. So the question is, at what temperature in Celsius will the volume be 3.87? So in a way, I have two temperatures, two volumes. So I'm going to use that equation, the appropriate equation that has volume and temperature in it. So I use the appropriate equation as volume and temperature. So again, these are the different equations. I need to use the equation that has volume and temperature. Volume and temperature. There should be two T's and two V's in it, and not other stuff. Two V's and two T's in it. So, I mean, it wouldn't be this P equals nRT equation. There's only one P, one T. And there's also V's and R's and N's, stuff that I don't need for this. The equation I have to use that has V's and T's would be this equation right here. The volume and temperature equation. Again, you don't need to know the name of it. Okay, you don't need to know the name of the equation, but I believe that one is Charles' law. So we're going to use this equation, V1 over T1 equals V2 over T2. I'm going to write that down, that equation. V1 over T1 equals V2 over T2. I'm actually solving for T2. Oh, I forgot to write liters there. So I'm trying to technically solve for T2. That's the question. You can just plug everything in, and that's fine, and then just solve for it, or you can do it in variable form. I'm just going to plug it in. But before we plug it in, there's one thing that is missing. The temperature. It says it's 65 Celsius. All temperatures and equations must be in kelvins. So I have to add 273. So I have to add 273. So 65 plus 273. I need my phone for this. Plus plus 273. That is 338 kelvins. So T1 is actually 338. So don't plug 65 in, plug in 338. All temperatures in all the equations, all temperatures in all these equations must be in kelvins. Okay, let me plug everything in. So V1 was 4.22 liters. T1 is 338. V2 is 3.87. And T2, I'm just going to call it X right now. Okay. Well, I mean, I probably just left it as T2. That's what I'm trying to find. But I'm going to say X. I'm solving for X. So isolate the variable. And so, probably what might be easier here, I'm going to cross multiply. So it might be, well, it's easier for me. I'm going to just cross multiply. So I'm also going to leave out the units right now, but maybe I shouldn't. 4.22 times X is equal to 338 times 3.87. So, and we're trying to solve for X. X is equal to 338 times 3.87, all divided by 4.22. And on my calculator, 3.87 divided by 4.22, I got 310. You're like, 310? The answer says it's 37. How in the world did you get 310 when even the book says the answer is 37? I'm not done. I solve for the temperature. But remember, when you solve for the temperature, temperature will always be in every equation will be in kelvins. So temperature is in kelvins. If the question says, what is the Celsius temperature? Well, if Kelvin is Celsius plus 273, if I want to have Celsius, I should subtract 273. So I'm going to subtract 273. And if I did that, I'd get 37 degrees Celsius. In other words, 37 degrees Celsius is 310 kelvins. They are the same thing. So the type of problems on the test, it could be something like this. Okay? It could be something like this. You'll be given all the equations, but you need to use the appropriate equation. Which equation should you use? I don't know. It kind of depends. It depends on what is given. So it depends on what is given. So let me pull up another question. Okay, I now want to do this problem here. This is 13b. It says, how many moles are contained in each of the following at STP? 5.6 liters of, that's a 5.6 liters of chlorine. So that's obviously a volume because it says liters. There's another thing it says, STP. STP, that term, standard temperature and pressure. You're going to have to know this term. You're going to have to know this term. I actually went through the notes. If you watch chapter 10 notes, part, I think 3, about ideal gas law, I talk about what is standard temperature and pressure. The term standard temperature and pressure means 0 degrees Celsius, 1 atmosphere. Standard temperature and pressure is 0 degrees Celsius, 1 atmosphere. Standard temperature and pressure is 0 degrees Celsius, 1 atmosphere. So when it says it's at STP, that means it is 0 degrees Celsius and 1 atmosphere. That's what STP means. So you need to know that term. So I know the volume, I know the temperature, I know the pressure. The question is, what is the number of moles? N stands for moles. So I need an equation with volume, T, temperature, P, pressure, N, moles. So I need an equation that has P, T, V, N's. And there is one equation like that that has V, P, N's, and T's. There's also another variable in it, and I think you could see which equation I need to use. It's obviously not going to be this one. There is no T in it. It's not going to be that one. It's not this one. That's a molar mass of a gas. We're going to use the ideal gas law, PV equals nRT, where R, by the way, it will be given to you, is 0.0821 liters atmospheres per mole Kelvin. So let me write the equation down. PV equals nRT is the equation we're going to use. And we will, you'll be given R is equal to 0.0821 liters atmospheres per mole Kelvin. That's also in a way given. Okay, well, knowing that, we can solve for N. We can just start plugging it in. P is 1 atmosphere. V is 5.6 liters. N is, well, that's what I'm trying to find. N is question mark. R is 0.0821 liters atmospheres over mole Kelvin. Temperature, it's, oh, don't plug in 0. I was going to plug it in, but remember, all temperatures in all the equations, all temperatures in all equations must be in kelvins. If it's 0 degrees Celsius, that is, if C equals 0, Kelvin temperature is 273. 273 kelvins. Just make sure all temperatures are in kelvins. We are trying to solve for N. We're trying to solve for N, that variable. So divide both sides by 0.0821 and 273. I'm not going to show that. I'm just going to assume you know how to do algebra. Okay, so plug it into a calculator, and let me do this on my phone. 5.6 divided by 0.0821 and 273. And I got 0.25, quarter. 0.25 moles. So 0.25 moles. So how do I know what equation to use when we have these? And again, you don't need to memorize the equations. They will be given to you on the test. You do not need to memorize the equations. They will be given to you on the test. So how do I know what equation to use? It kind of depends on the question. It kind of depends on the given. But use the appropriate equation, and there are 7 of them. Use the appropriate equation to solve for the question. And so let me show you what kind of questions there are in the test. So the chapter 10 and 11 test review guide. This is posted in a folder for on Schoology. So if it's on here, it's on the test. It says, notice all numbers were removed. So there will be questions like, let me look at number 14 randomly. The volume of gas is some number. The temperature is some number. If the temperature is reduced to some other number that I deleted without changing the pressure, what is the new volume? Question number 16. A gas has some milliliters at standard temperature, by the way, that's 0 degrees Celsius. What will the volume does it occupy at some other temperature in Celsius if the pressure remains constant? So notice there's a lot of X's on here, and they are numbers. So on the test, you will actually have numbers, of course. But on here, what I did was I just removed all numbers on the guide. These are pretty much the test questions, minus the actual question, minus the actual numbers. So in the folder for February 23rd, 26, here at least, you'll see the Chapter 10-11 test guide. Okay, Chapter 10-11 test guide. And also for your reference, the Chapter 10-11 notes, which were all these notes on here. Okay, that you've already seen, the Chapter 10 notes, Part 1, 2, 3, 4. So that is what's going to be on the test next class. Or, well, I shouldn't say necessarily next class, the next time I see you, which would be, well, I'll post it on Schoology.